We will start with a question. I ask this question and love asking it at a variety of conferences. See, we will talk about Linux, only about Linux, not about BSD, not about Cisco. Every time you want to look up at an address or to set up the network, what is your favorite utility? What is your favorite utility? ifconfig. Is there anyone who uses ifconfig? Because usually at conference, userspace, we say userspace. Everybody and so because deprecated, never used for, haven't been used for like 20 years. Okay, let me take a chair. ifconfig, say, and when we say it's deprecated, say they are surprised. But when I come over here, IPRoute, that's the answer, and there is no surprise. Say, and that's why I lose this intrigue at the start of my presentation. ifconfig has issues, well-known issues. ICTL is used as an interface to the kernel. It's very limited, and it bothered for quite some time many, and there were attempts to go outside of this interface, IT tables. Have you ever seen how IT table works with the kernel? That's a separate, beautiful story, because it goes to a socket and gets the sets scoped and gets the settings. There are Unix way, a well-tried and tested old tool using virtual file system like Plan9, but we're talking about Linux, right? Also, there are specific protocols working with kernels. FK, IPsec, and IPRoute2 using AF Netlink. And this is it for the most cases. And there are libraries, ID panel, well known. How it was bypassed by Python? No, there was no specific bypass. They just used ifconfig. So, and now I'm telling you about Python. So I'm a bit confused. However, so you just call the utility in the command line. Just take shell and then start ifconfig. It works. That's how OpenStack worked for quite some time. And it works like this even now. Until finally, so the Stone Age was replaced by the Bronze Age, and we have IPRoute. It was originally made like an interface between the pattern and Netlink. It was simple, and it is simple, quite simple even now. So it's not like a mapping of the IPRoute package, but it's a mapping of the ITRL protocol. Get the address, like get the route, make the route. Here is a variety of Netlink's options. Netlink, it's more than just setting up addresses and interfaces. It has a huge list, including monitoring of the system via a variety of parameters where you can get information on disk quotas. For example, disk quotas are above the limit. You may get this information. So there was no interface with the Python, but then it was written initially from Info5 C-types was used, and then it was identified that C-type is a great thing because it can fail by itself, or it breaks C Linux. And it was rewritten for Python. So it's a sad story, but it is thousands times faster than calling the external utilite and parsing it. That's how we did it before. Before optimizing the code. This is the entire API. They open the socket, send the package, receive the package. This is it. It is extremely simple. Netlink is very simple. I didn't have even slides detailing you the package structure because it's extremely simple again. Just the heading, the length, the type of the package with the designated fields and the data. Done. The data has like the C structure, the similar C structure, with a similar type packages, the length, the type, the data. Done. So you can even use binary data for writing it. So Netlink has some interesting points because it has the notification from the kernel to the user space. That's very important. This is what is missing in many cases when you work with the network to find what happened to the network, not through the spalling of the whole system, calling of the whole system, but you just listen to the events and you get the events, and you identify that it's not because you get it periodically, but you get notifications. What's wrong? IPRoute users know it. IP mode, that's exactly. You start the IP monitor and you see all of these notifications. So house wanted it, and it happened. The interface that initially was designed as a simple card of maps, just to lift interface, add the route, remove the route. So it has an experimental module where everything that was done as transactions. And this module had big letters, capital letters. It was experimental, not working. There are bugs that don't come into it, but everybody went to this module. So I work with users' feedback back, analyzing it. And very often, this module is used. So, because of that, let me tell a bit about the architecture and the way it grew. Binary data which arrives from socket Netlink. Sockets, they are parsed into Python structures. Above them, we have specific classes, Python classes, which add to the regular sender package, receiver package specific functions. Collect the Netlink package and disassemble. Assemble, disassemble at the Netlink level. And then other.
A bit higher, there are specific functions with IPRoute dealing with lifting and lowering interfaces. IPset is doing its work as well. And that's the way the structure of the package looks like when you get it in the Python. Well, it's not that difficult in principle. And the goal of the library was to make it as simple as possible to avoid the bugs. The less we do, the less bugs. So everybody went to the transaction model, and that's where the bugs are. On the level of the Netlink, the addresses have nothing in common with the interfaces besides one attribute. So you have separate packages for everything. On the IPDB level, we've just aggregated all this info where the addresses are related to interfaces, and the result was as follows. The structure was a bit more intricate. A big and beautiful slide. Let's talk about mathematics. The set of attributes, whether it's the route or the interface, maybe it's a set. The initial condition of the object is the set. The purpose condition is a set as well. And the difference of sets is what may be taken off from the object or added to the object. Now, where did it go? Something horrible was pushed. We have the target condition of the object, and then this is simply an operation with sets. If you work with Python structures, that's the way it looks like. To a certain interface, we've added an address. Here it is to the right, or we deleted the address. It was either lifted or lowered. Next details are coming. With addresses, everything is simple. You remove or add them. But if these are flag-like attributes, we have to map the work with the dictionary into the sets. But from the point of view of mathematics, it's pretty much the same. These are details of realization. And this is same transaction recorded in the structures. And that's the way it looks like from the point of view of the program. You have the network object, say the interface, and when you create the transaction, there is created just a copy of this object where all the modifications are included. And with the commit command, the difference of these sets is calculated and it is applied. In case when everything works, it's not that interesting. That's the simplest case. Everything works, everything is fine, and the transaction isn't that necessary. The problem is when the error takes place. How do you step back? And then instead of recording everything, we do into a separate log, and then redo it, we just switch the places. In the beginning of the transaction, we do the snapshot of the object from the point of view of the Netlink, and we store it. And in case of a successful application of the settings, we just throw it away. But in case of an error, we are using this snapshot as a transaction, as the target objective condition of the object. We just swap the places, and no matter what was applied or not applied before or after, before the error. If there was an error during the transaction, we use the initial condition as the objective one. From the point of view of mathematics, everything is simple. That's the way it looks like. Well, say.
И, в принципе, опять же, все довольно просто до тех пор, пока у вас ошибка касается только одного объекта. Допустим, у вас случилась ошибка при настройке интерфейса, вы откатили состояние, все замечательно. А что делать, если ошибка случается, и у вас исчезают связанные объекты или меняются связанные объекты? У вас интерфейс.
Just a minute. I'll do it this way, not to reset everything. Sorry, the resolution went wrong.
И я скажу даже еще более страшную вещь. Все казалось просто, когда мы начинали работать над этим проектом, потому что казалось, вот у вас есть изменения в системе, и у вас идет уведомление. И оказалось,
Well,
что
say
некоторые
we've
изменения в системе, они
created
порождают уведомления в Netlink, а некоторые не порождают. Некоторые порождают излишние
such a
уведомления, с
code.
которыми непонятно потом, что делать.
Is it readable or not?
В случае
Not
маршрутов
from
это
the
именно так.
point
У
of view
вас,
of the
если
fonts,
вы
but
удаляете
whether you
интерфейс
can
или
tell what
снимаете
is written
адрес
there
и
or not.
пропадает связанный
I've
маршрут, вы
tried
не получаете
to make
никаких
it
уведомлений.
as
Вы просто по
simple
факту туда
as
заглянули, и
possible.
вот
The
так
main
будет.
thing we see is that Vim is
Поэтому
great.
простая библиотека изначально. То есть на уровне IPRoute там все просто так и осталось. У вас простые функции добавляем, удаляем, изменяем. На уровне IPDB все это превратилось в кромешный ад. Это не то, что один большой костыль, это изрядная коллекция костылей, без которых, собственно говоря, это довольно сложно получается. У вас сетевые интерфейсы, которые dummy интерфейсы, они посылают уведомления об адресах IPv6, а Bridge Bond не посылает. Но только если опущен. А если поднят,
What was it? The test? Here you are. Test.
Рассказывать можно бесконечно, потому что за вот прошедшие годы занятий, собственно, с этим
You may
проектом,
add
вся
things
вот эта мудрость
to
поколений,
it.
она там осела в виде функции commit.
Okay,
Если кому-то хочется
let's enter the
погрузиться в
already
бездны
started
ада,
one.
они могут это сделать, просто открываете код, лезете в commit и понимаете, что нет, что я сейчас
Pay attention at this instance on Eton. It was started a while ago. I didn't touch it. In a magic way, everything appears there. It doesn't pull the system. It is just waiting for the notice. If the notice came, it works. If it didn't work.
Здесь мы сейчас получим просто shell, а здесь мы запустим мониторинг операций.
Here you are. Where is it? Here it is, the last one. 3 addresses on the interface. And in principle, again, everything is rather simple till the error is regarding one object only. Say you had it at the interface setting, you came back to the initial condition, and everything is fine. But what if the error takes place and connected objects disappear? Say the interface was deleted or the interface address and the routes went off. They just physically disappear. Well, I'll tell you more. Everything seemed simple when we started to work on this project. There seemed to be modifications in the system, and there was a notice. And certain modifications of the system create too many notifications that you don't know what to do with. In case with routes, that's the way it is. If you delete the interface or take off the address and related routes disappear, you do not get any notifications. You just get to know about it when you look at it. It's quite a surprise. So initially, the library is very simple. On the level of IPRoute, everything remains the same. The simple functions, you do that. But on the IPDB level, it all turned into hell. It's not just one small crutch. It's quite a big collection of crutches that you are forced to use, and you can't do without them. The network interfaces and distant interfaces, they send the modifications on the addresses of IPv6, but the rich one don't do that. Only if they're lowered, but if they're up, they're sending. So it's, I can tell you about it for quite a long time. I've been dealing with the project for quite a while, and all that wisdom of generations sedimented over there in the shape of the commit function. If you want to get into the hell, bottomless hell, you get into commit, and you want to close it right away. This new continent. Some things it's better not to know them. However, we tried to overcome this difficulty, and we did it with quite a success in a way. Now here we'll get just a shell, and here we'll start the monitoring of operations. First, let me tell you what it is about. We have the interface, we have the address, and the static route, which is done via this address. As soon as we delete the interface, the route will disappear. But in the very beginning, we have the function that tells, wait, we need this address to be accessible, irrelevant of the network configuration of our choice. It has to be, well, Google has to be available always. After that, you set this interface, all of a sudden the Google becomes unavailable, inaccessible. Right away, this will happen. It worked quickly. Couldn't show you all the beauty. Let me try once again, maybe it will work slower. Still it works too quickly. Oh dear, well, doesn't matter. Nevertheless, you see that first we delete the interface, then the route connected with all this. And next, it says, it's inaccessible, and it goes back, all the way back. Great, now let's delete it. I'll do it manually. It's a little bit more intricate. It's going to be a bit more intricate. We create two ports, the first and the second, not the Chinese. We make a bridge, we add the ports, the address, same route, and after that, we try to delete or drop that bridge. Doesn't matter. We've set up everything. We get to know that everything works. We have the ports, we have the bridge. Who said that UTF-8 is evil? No, it's virtue. You see virtue on this screen. You may name it in Russian, no matter. Doesn't matter. Everything works within 16 bytes. Anything you want. We get convinced that the route is still in place. That's one more thing that can't be done with the help of the older utilities like route and config. We've added the static route to the table 100. Does anybody here work with several routing tables? How many? What's the limit? 2? More? 5? several hundred. Well, the thing is that initially it was within the byte. It was included in the Netlink, and within 2 bytes. That's it. Now we'll try to remove this bridge. Now I'll remind you the script that does it, same things. We'll get convinced that it's available, and if not, the transaction gets the error at exit. Now it's slower, but not much slower, I'm sorry. Same result. Here you get notices on ports that they were switched off from the bridge, that everything went wrong. And everything added up. The addresses were removed, deleted, and so were the routes. Next, the system is scaled. Pyroute may work with remote copies. You may make a connected transaction on several hubs. That's the beauty. Well, naturally, if you break the connection between them, it doesn't help the business, but it helps you to get back with the transaction. Does anybody of you work with Cisco? Did you ever do the settings of Cisco in the switches? You set the switch, and then you do the setting to switch off the management alarm. Of course, you do it on purpose, that's clear, but you can do it just by chance to avoid the situation. Did any of you try to do any measures besides the person with the reset? With timeout, yeah. You just install the reboot in 5 minutes. After that, you change the configuration, lose the switch on operation, but in 5 minutes it will get reloaded because VRM wasn't done. Same story may happen here. It's implicit in this library. You don't have to do the reloading of the whole hub. It will do it automatically in 5 minutes. Just a sec. It does work. That's the way it works. That's the way it's done. From the point of view of the library, in case of an error, the target and initial condition simply swap places. No matter what was applied, it doesn't have to know what was applied, and simply brings it to a certain condition. Next, sad story about the architectural errors or mistakes or drawbacks in the Netlink. Exactly in RTNL, there's plenty of those drawbacks, and if you want to work with RTNL and do not want to use high-level utilities, but you want to work on the low level, first do take the high-level utility and read how those crutches are written over there, since there's plenty of those crutches. Sorry. It's a very simple protocol. We have the length, the type, the data. One may work with it anyway. Since it's done the way you can work with it anyway in the kernel, this is done anyway. Literally, they do with it whatever they want. Each author who works with the Netlink, at present there are hundreds of contributors, and each one is working in his own style. Absolutely. Everyone has his own unique style. Sometimes you recognize them by this style. The problem is that you're familiar with the style, but you have to write crutches for different authors.
So, well, very often during our project is already debugged, optimized. So trust me, bugs are, there is a sea of bugs. The library comes over them. Like I worked this night, the library doesn't know how to, if there is a mistake, how to replicate the VLAN filters. It cannot roll everything back. So, because it's very complicated, because there are several ways of putting together dependable objects, and you will lose productivity. So I know it happens. However, the productivity in this library is one of the key bottlenecks. It's a sore point. So you have to monitor the productivity, whether it slows down, because if it slows, it falls
Не обращайте
down
внимания, пожалуйста.
several-fold, hundreds-fold.
Здравствуйте. Расскажите, ну, например, use case, да, есть VLAN, есть bonding девайсы, есть IP, есть рауты. 4 уровня dependency между объектами. Расскажите о том, как вы, ну, о ваших костылях, да, которые, соответственно, следят за зависимостью между объектами. Как это сделано, и можно ли вот 4 уровня, которых я описал, потянет ли она, да, и что надо, чтобы потянуло?
Да, спасибо. Тут все немножко проще, чем 4 уровня, потому что зависимость между бondами, VLAN и всем остальным — это зависимость между интерфейсами. Это с точки зрения библиотеки один уровень.
That's the only thing. There is another library written by Facebook people, and they took my library and then using it as a base offered a product. They tested the throughput of their networks. They looked at the whole field. They wanted to enhance it, and they rewrote it from zero level. So they work with IPsat. However, we work with IPsat, and we have in our project data from IPRoute, and we thank them immensely for using their data. But if somebody wants and volunteers to do it better, be my guest. Say, I monitored Python libraries for quite some time, many years, and I look for a competitive product. So you have to do it better. Somebody has to do it.
Cool.
And I
Any more questions?
to boast a little bit,
Пожалуйста.
because I wanted to show you like
доклад.
a number of
Вопрос
bugs and
такой.
our fixes to it.
Поддерживает
Well,
Pyroute
it's not perfect yet, but
namespace, сетевые
nobody's better than
namespace?
us
Да,
yet.
еще как. На данный момент есть библиотека, которая заточена в питоне только под namespace. После этого ребята говорят, вы можете запустить функцию в определенном namespace. Вы ставите декоратор, и функция запускается в namespace. Что делает этот декоратор? Он просто делает SetNS. Что делает SetNS, когда вы его запускаете в процессе? Весь процесс выкидывает в этот namespace. Если у вас многопоточное приложение, которое целиком улетает в этот namespace, у вас ни одна функция исполнится в этом namespace, а все, что случайно в этот момент попалось. Поэтому мы делаем как? Поскольку Pyroute, он прозрачно работает с другими экземплярами Pyroute, он просто берет и запускает дочерний процесс. Тяжело? Да, но надежно. Дочерний процесс работает.
Energy left. Do you have any questions, suggestions?
Как это происходит? То есть с точки зрения программирования у вас только даете имя namespace.
Please.
С namespace.
Ну, это меня программа зомбирует.
IPDB работает в вашем материнском, в главном namespace, в host namespace. Но при этом все его операции выполняются в целевом namespace.
Let us take US case. There are VLANs, bonding devices, IP and routes, like 4 dependent
Микрофон, пожалуйста.
between entities.
Спасибо за доклад. Скажите, пожалуйста, что с конкурентным выполнением и обращением к вашей библиотеке? Если мы одновременно пытаемся запустить 2 транзакции, что произойдет?
See how you did it, and I gave you 4 levels. Whether your system will manage these 4 levels? The answer. It is simpler than 4 levels, because dependence between bonds, VLANs, and other things. See, from the library standpoint, it's just one level. So the same code operates, is an operation. And it doesn't care whether VLANs are put on the bonding and what substructure and superstructure you have, because the same code will be used and the same fork, which monitors the dependency to the next, goes with the dependency to the next level, and the library doesn't cover the whole transaction, the whole stack. Each transaction is related to its level and then generates the
Коля?
next transaction, which will work on the next level. So the forking works only at one case between the dependencies between interfaces and dependencies between addresses and routes. Then a different code is used.
Примитивы там
But
RTNL
otherwise, the same code is
изначально
used.
были только RTNL. Но на данный момент он умеет работать с виланами,
Спасибо,
работает с
хорошо.
IPsec,
You have a good presentation.
с IP-сетом,
My question:
работает с iSCSI,
whether
работает с
Pyroute supports namespaces and network namespaces.
на самом деле на
It
20 местах
does.
прилагается.
It does it very well.
Вот,
So
поэтому да, можно
Python
вплоть до того, что
library
сетапить
is in fact geared to this,
через
and then you can start the function from a certain namespace, and you have the decorator. The decorator does set an S. And then when you do it in the process, the whole process goes into
Wow,
this
any more questions?
space. And then
Great.
this case in net
So
space,
if we are
it's
finished
not,
with...
works not only this function, but everything which happened to be in this second.
И на текущий момент у нас закончились вопросы, тогда ловим докладчика живьем в процессе кофе-брейка, который у нас сейчас по программе.